Hey, what's up? This is Ncert here, and I have come up with very next topic from aldehyde, ketones, and carboxylic. And in case you are watching it regularly, you probably understand that I'll be talking about physical properties of aldehyde and ketones. And in case you do not, and you are really interested in knowing what exactly I have done in this chapter, you can go and check out the other videos and that I've made in last couple of days. So right now the topic I have is called physical properties of aldehyde and ketone. So let's do. I will talk about four of the aspects of properties. The first I will talk about states, right? The second I will talk about the boiling point, right? And third I will talk about solubility, and the last one will going to be order, ODO, EVA. So these are the four topics I'll be considering right now as per the NCERT, and then I'll in the next session I will start your chemical properties. But before that, let's talk about the state here, right? So physical state I'm talking. The first thing you have is that lower aldehydes like methanol is a gas. Similarly, lower ketones like acetone or acetone is a liquid, right? But if you talk about ethanol, it is a liquid. So ethanol is a liquid. So what I'm trying to say is that up to 1, 2 and 3 carbon aldehyde and ketones are gases or liquid, but higher members, what higher members here? Aldehyde and ketones with more than 3 carbon or more than 3-4 carbon. So but higher ones are solid. So that is your statement part, but we need to find out why the initial few members with 1, 2, 3 carbon they are gases, and 3, 4, 5, 6 and more they are going to be solid. Now it's a simple reason that less the number of carbon, small will be the magnitude of van der Waals force of attraction. But as the number of carbon increases, the van der Waals force of attraction increases due to increase in the mass, right? So let me repeat that. Less the number of carbon, less will be van der Waals force of attraction, less van der Waals forces, right? And less van der Waals forces due to smaller mass, and because the mass is smaller, so van der Waals force is smaller, and therefore they are either gaseous or liquid, right? That is the thing. Now let's talk with the next one. More the number of carbon, greater will be force of attraction, greater van der Waals forces, and due to higher masses, and therefore, they exist as a solid, right? So, like I said, initial 1 and 2 member of aldehyde and ketones, these are gaseous, but beyond 2, 3, 4, 5, 6, they are all, solid, right? So, why this happened? Because small the number of carbon, small will be the van der Waals force of attraction between the molecules, but as you increase the number of carbon, the van der Waals force of attraction increases due to increase in the mass, and hence they become solid. So, this is what the very important first properties I made you go. I hope I have written enough, and that's going to help you. Let's talk about the boiling point. So, the second one we have is the boiling point. Boiling point. Now, aldehyde and ketones, aldehyde and ketones have higher boiling point than hydrocarbon with comparable masses, right? Okay, what that mean? If let's talk about an example here. Suppose I'm talking about ethanol. Right? Then I'm comparing with the ethane here. Ethane. So ethanol boiling point is going to be higher, right? This has a higher boiling point. This has a higher boiling point, and this has a lower boiling point. I hope you don't have problem when I write this boiling point as BP, but this seems to be confusing. Anyway, now the question is, why ethanol has higher boiling points compared to ethane? Because this is a polar molecule. And there it is non-polar. So what that means? It is a less polar or non-polar. So if the polarity increases, the boiling points also increases, right? So this doesn't seem to be right. So ethanol is a polar molecule while ethane is a non-polar. So it has higher boiling point. This one has a lower boiling point. But if you compare, aldehyde, any aldehyde I'm talking, aldehyde or ketones with alcohol, then alcohol has higher boiling point. This one has higher boiling point, but this one has lower boiling point. Right? Now the question is why this is so. Let's talk about the reason. This one has hydrogen bonding. It exhibits presence of hydrogen bonding. Presence of H bond between the molecules. Because alcohols have hydrogen bond between their molecules, so they have higher boiling point, but they lack hydrogen bond. So they have lower boiling point, lower level hydrogen bond between the molecules, right? So if you compare aldehyde with alcohol boiling point is going to be higher, while aldehyde and ketones they are going to be lower boiling point, because this has a hydrogen bond, but this one doesn't have a hydrogen bond. Similarly, if you compare here ethanol with ethanol, then they are going to have a higher boiling point than hydrocarbon. So let's write this simple statement here, that aldehyde or ketones have higher boiling point than hydrocarbon. with comparable masses. Comparable masses. Right? Okay, now let me discuss the things back again. Aldehydes and ketones have higher boiling point as compared to hydrocarbon. Why? Because hydrocarbons are non-polar, but aldehyde and ketones are polar. But when you compare aldehyde and ketones with alcohol, alcohol boiling point is higher than aldehyde and ketones because alcohol contain hydrogen bond which is absent in aldehyde and ketones. Right? So this is what boiling point is about, and the trends you can consider. Now let's talk about the third property. So I have to remove this off. So the third physical property is going to be solubility. The very simple thing I would say, that both aldehydes and ketones are water soluble. Because they can form hydrogen bond with water. They can form hydrogen bond with water. But their solubility is less than alcohol. Because alcohol exhibit extensive intermolecular hydrogen bonding. Intermolecular H bonding. But aldehydes and ketones not. But aldehyde and ketones lack that much. Okay, let me repeat. I've been writing too much here. I would say both aldehyde and ketones are water soluble, right? Like alcohol, they are water soluble. Unlike hydrocarbon, why they are soluble? Because they are polar, but they do not form, that much of hydrogen bond with water like the alcohol. So they have a slightly less solubility with water as compared to alcohol. So what I would say, alcohol have extensive network of hydrogen bond with water and between themselves, so they are highly soluble, but the aldehyde and ketone solubility is slightly less than the alcohol because they are polar. They can also form hydrogen bond, but the network of hydrogen bond is not that much, just like the alcohol. So I have written everything aspect of that. If you can copy and have your information ready here, you can understand very much easily. Right? So solubility depends on the extent of hydrogen bond, which is more in case of alcohol, but slightly less in case of aldehyde and ketone, and that's why their solubility is less. So what that means, aldehyde and ketones are highly soluble in organic solvent, right? Because they are less polar. So I would say, with increase in, very important line here, with more number of carbon, the solubility rapidly decreases. Right? Because if you want to know the reason, because hydrophobic nature increases. right? So this is very important. Aldehyde and ketones, they are water soluble, but only the lower aldehyde and ketones are water soluble. The higher ones with more number of carbon, they cannot dissolve in water, because with increase in number of carbon, you probably understand that number of carbon if increases, it increases the hydrophobic nature of the aldehyde and ketones, and therefore the solubility decreases fastly. What that means? That the larger molecules of aldehyde and ketones are easily soluble in organic solvent, but the lower molecules are soluble in water, right? I'm not going to write everything because I've written already that too much, right? So solubility is about, this, like everything I said. Let me repeat one last line. Aldehyde and ketones are water soluble, but they are less than alcohol, because alcohol has extensive network of hydrogen bond, while aldehyde and ketones do not. Right? But if you increase the number of carbon, if you consider about some larger aldehyde and ketones with 6, 7, 8 and hundreds of carbon, they are going to be water insoluble, because with increase in number of carbon, the hydrophobic nature increases. What that means? The hydrophobicity increases, so they lose their affection towards the water, right? So higher ones are soluble in organic, but the lower ones are soluble in water. So the fourth, important topic I'm going to let you know is order. So what this order is, aldehyde and ketones with aldehyde and ketones with one to three carbon. 1 to 3 carbon are having order, but higher members do not. Higher members do not, are orderless. Right? So what that means, that aldehyde and ketones with a few carbon, they have their order, but those with large number of carbon, they are orderless. They do not have a smell. Why? Because as the number of carbon increases in aldehyde and ketones or any compound, what happens? Their volatility decreases. So with increase in number of carbon, one last thing, increase in number of carbon decreases the volatility, sorry, right? So higher members are orderless. Right? So this is how, 4 of these, topic I have mentioned, and I have explained every bit of that, because, the aldehyde and ketones with small number of carbon, they are having order. So they are used in making, so many fragrance giving objects or, material and all that. I don't know what are the examples you can have, but if an aldehyde and ketones, you find it has smell, it has order, it has fragrance, then it must be lower aldehyde and ketones, because the higher ones cannot evaporate, cannot be volatile, because they have higher magnitude of van der Waals force of attraction, and that makes them non-volatile. So if they are non-volatile, they cannot produce, vapor, and if they cannot produce vapor, their diffusion is not possible, and they are not diffusing, they are going to be orderless. So these were actually the topic in NCERT, as a physical properties of aldehyde and ketones. You do study and let me know. So thanks for watching, and don't forget, to come back again and watch the very next topic, because this is really very important chapter. I would say thank you very much.